Okay, in this final video, introducing L'Hopital's rule, we're going to look at the limit as x approaches 1 from the right of 1 over ln of x minus 1 over x minus 1. And if we were to plug in values of x as they approach 1 from the right, we would see that natural log of x is approaching 0. Natural log of x is approaching 0. Yes, so we get 1 over 0, which is infinity. And then as x is approaching 1 from the right, we're also getting 0 in 1 over x minus 1. So we're going to have 1 over infinity, 1 over 0 again, which is infinity, leading us to an infinity minus infinity scenario. So once again, as x approaches 1 from the right, 1 over ln of x is going to infinity. And 1 over x minus 1 is also approaching infinity. And so we have an infinity minus infinity scenario. And the way we do this is the way we work with this is find a common denominator. And since we have factors of ln of x and x minus 1, we're going to need to have a common denominator of ln of x times x minus 1. So multiplying the top and bottom of 1 over ln of x by x minus 1, we're going to get x minus 1 divided by x minus 1 times ln of x. Multiplying 1 over x minus 1 by ln of x over ln of x, we get ln of x over x minus 1 times ln of x. Anyway, so we can combine these both over the common denominator. And we can try to plug in again. So as x is approaching 1 from the right, 1 minus 1 or x minus 1 is going to approach 0. And ln of x is also going to approach 0. So that should give us a 0 in the numerator. And in the denominator, we're going to end up with 0 times 0. So we have a form to which L'Hopital's rule can be applied directly. Now the derivative of the numerator is going to become 1 minus 1 over x. And the derivative of the denominator, a little bit more complicated, we'll have to use the product rule for. So we have 1 d2. So we have x minus 1, quantity, times 1 over x. So that's 1 d2 plus 2 d1. And the derivative of x minus 1 is just 1. So we end up with x minus 1 times 1 over x plus ln of x. Now again, as we plug in x values as x approaches 1 from the right, in the numerator we are going to get a 0. But instead we might want to multiply top and bottom by x. And that'll simplify the fractions, or that will give us a simple fraction which has only a simplified numerator and denominator. So multiplying the numerator by x, we end up with simply x minus 1. Multiplying the denominator by x, the 1 over x will cancel, and we will get x minus 1 plus x times ln of x. And that's a lot simpler. Now don't be tempted to cancel the x minus 1's, because x minus 1 is not a factor of the denominator. However, as we plug in values of x as x approaches 1 from the right, we're going to approach 0 in the numerator. And we're also going to approach 0 in the denominator, because obviously x minus 1 as x approaches 1 from the right will be 0. Then the natural log of x will also be 0, and that will make that term 0 also. And so that's going to give us 0 over 0, which allows us to apply L'Hopital's rule again. This time the derivative of the numerator is simply 1. The derivative of the denominator is going to be 1, then plus the derivative of x ln of x, which we'll need the product rule for. So that will be 1 d2, giving us x times 1 over x, plus 2 d1 just leaves us with natural log of x. Simplifying that gives us the limit as x approaches 1 from the right of 1 over 2 plus the natural log of x for a final value of 1/2. So that brings us to the end of this problem and this video.